Sorry, folks, I got cut off there. This is part 2 yet of that lesson for our second lesson 1.2 in our first module. It's all about angles, and as I was saying, there's some scenarios where we're going to be talking about a bisector. So if you look at our picture here that I've drawn, this ray BE here running down through the middle, it's going to bisect the overall angle ABD. Okay, now, when it comes to bisector problems like these, there's a couple of scenarios that might happen. They might give you each of the two individual angles here. You know, for example, they might say that this part here is 6x plus 2, and then this part down here, the other half of it is 8x minus 14. Okay, so if that's the case, this is, I think, a rather easy problem. If you understand that a bisector is going to cut something into two equal halves, this top half and this bottom half here are going to be the same. They're going to be equal. We don't need to know what they add up to as a total like we did on the previous problem. In this case, I could simply say that this is going to equal that. And just go from there. I could solve that for x. Okay, remember what I was talking about just a little bit ago about when you look at an equation like this, there's the two halves. I've got multiple x's again. Okay, the one I did earlier, remember I called a sheriff-deputy situation because the x's were on the same side. Okay, in this case, this is what I call a sheriff-bandit situation. Because I want you to notice that our x's are on opposite sides. Okay, so I call this sheriff-bandit because a sheriff and a bandit would be on opposite sides of the law. Okay, it's done a little differently then. In sheriff-deputy, they joined forces. A sheriff and a deputy worked together. They were like terms, so they combined. In this case, since they're already on opposite sides, though, we cannot go ahead and do any of the joining of like terms. This is, again, is what I call a sheriff-bandit situation, and a sheriff and a bandit wouldn't get together anyways, right? Since they're on opposite sides, just like in the Old West movies, the opposite sides when they run when they run into each other at town, okay, in every classic Western movie, you know what it looks like. They all get out in the middle of the road, they get all antsy, and they get ready to grab their gun. They're going to have a shootout, right? They're going to take each other out. That's what's going to happen here. This is a sheriff and a bandit. They're on opposite sides. Okay, somebody's got to go. We got to get rid of somebody. Okay, now, I always like to say that according to Darwinism, it's survival of the fittest. Okay, so when you take a look at this one, 8x, 6x, I look for the one that's stronger and I'm going to keep him around. So the 8x is my stronger one. I'm going to keep him. Let's get rid of 6x then. Okay, so the 6x, to get rid of him, in algebra, you always just do the opposite. If I want to get rid of this whole term, 6x, which is being added, I'm going to get rid of it now by subtracting 6x. Whatever you do to one side, you got to do the other. Okay, so this will be gone. You'll just have your 2 left. Bring down your equal sign. 8x minus 6x is 2x. And bring down the minus 14. Again, from here on out, though, as soon as you get it down to just 1x, most of you know what to do here. Remember I said earlier it's that PEMDAS, only we're doing it backwards, so it's really beside me. So you're looking for parentheses. There are none. You're looking to add or subtract. I see that if I want to get this x by itself, I need to get rid of the 14. Since it's being subtracted, I can get rid of it by adding or subtracting. So I'm going to add 14. Whatever I do to one side, I've got to do the other. So that's gone. Now you just have 2x. Okay, again, I'm trying to get the x by itself. So to get rid of that x now, I got to get rid of the 2. That 2 is being multiplied, so to get rid of it, I'm going to divide. And whatever I do to one side, I got to do the other. If you haven't figured out yet, I got past the adding and subtracting. We just did the dividing part. Multiply, divide, see? And there is no exponents. X is 8. You could even end up plugging it back in. You could plug it back into here and here and get each of your measurements. Okay, if I plug that 8 back in, 6 times 8 would be 48 plus 2 is 50. So that angle would be 50 degrees. And this one, plug in an 8. 8 times 8 is 64 minus 14 is also 50 degrees. Which makes sense. Again, it was a bisector. It was supposed to cut it into 2 equal parts. So it did. It cut it into 60 degrees for each of those. Okay. Now that's one type of bisecting problem where they just give you each individual half, you set the halves equal to each other. Okay, now the next one I'm going to show you is a little different. We're going to stick with the same thing. We're still going to have this ray down the middle be the bisector. Okay, but I think you're going to find the approach on this next one is going to be a little different though. Okay, so BE still is going to bisect the overall angle ABD. Okay, but on this problem, suppose that I told you that angle ABE, so ABE, this one in here, is 12x minus 8. And then, instead of giving you the other half down here, what if I told you the entire measurement all the way across there for angle ABD? So the measure of angle ABD is going to be then 22x minus 11. So 22x minus 11 for that entire stretch across there. All right, so now when I give it to you like this, the approach is a little different. You know, earlier I gave you this half and that half, you set the halves equal. You can't do that here. I hope you see this angle is much smaller than the overall angle. So you wouldn't say that equals that. Okay, but there's an easy way to fix this. You know, if these two halves are in fact equal, couldn't we call this down here another 12x minus 8? You know, they're equal after all if it's bisected. And then we could approach it by doing something like this. We can say that both of these, two of those together, two of the 12x minus 8s, two of those equals the overall angle. See that? The overall angle of 22x minus 11. So I'm saying these two together equals the whole thing, 22x minus 11. Okay, that's a true statement. That should be a good equation now. That should be an equation we could solve for x as well. Okay, and one of the things that you learned in algebra whenever you saw parentheses like this is to get rid of that. Remember that I told you, you know, PEMDAS is the normal order, but in algebra we do it backwards with the P still being first. Beside me? Well, that's what we're going to handle right here. We're going to handle that parenthesis right now. We're going to get rid of these parentheses though by distributing. You should have learned the distributive property back in algebra. Anything outside of here then is taken times everything inside the parentheses. So 2 times 12x is 24x. 2 times a negative 8 would be negative 16. And that equals 22x minus 11. Okay, so now, after getting rid of the parentheses, I hope you notice then that, like I was just mentioning earlier, we've got an equation where we've got a couple of x's. I noticed that they are on opposite sides, making it a sheriff and, do you remember? Remember, sheriff deputy are on the same side of the law. Sheriff bandit are on opposite sides of the law. My X's, as you can see, are right here and here, and they're on opposite sides. So this is a sheriff bandit situation. And remember, in sheriff bandit, they're gonna have a shootout. Okay, one of them has to go. You know, one of them's gonna kill the other one here, so to speak. Okay, and I always like to use Darwinism, survival of the fittest. This one's a little stronger, 24x than 22x. So let's get rid of the weaker one. If you're wondering why I always get rid of the weaker one, it helps me avoid too many negative numbers. If you always get rid of the smaller one here, and then whatever you do to one side, you got to do the other. The nice part is if you always get rid of the smaller one, here you always have a positive 2x, see? Bring down everything else, including that negative 11 over there. Be careful. Okay, at this point, again, you know, we just got to keep following this. So I want to do any adding or subtracting still here. Okay, so I see that if I want to get the x by itself over here on this side of the equation, I've got the 2 and the 16. If I want to do it by any adding or subtracting, I'm going to do the opposite of minus 16 and put a plus 16. Whatever I do to one side, I got to do the other. So now I've got 2x equals 5. Okay, and then in this case, to get rid of the 2, which is being multiplied, we're going to have to divide. We're up to this point now, multiply, divide. Okay, and 2 goes into there 2.5 times. So there's my x. I can always plug it back in to get each of my angles as well. Okay, so if I plug that 2.5 back in to either here, or you could even plug it into the total if you'd like. 2.5 times 12, let's see, that's, let's see, 24 plus another 6 would be 30. 30 minus 8 is 22. So this angle is 22 degrees. So this angle is 22 degrees. That means this overall angle should be 44 degrees. If you don't believe me, plug your 2.5 back in here. 2.5 times 22 would be 44 plus 11. 55. 55 minus 11 gets you down to 44. There you have it. So you should be able to handle any that even have bisectors in them. You know, if they just flat out give you each of the 2 halves, set the 2 halves equal to each other. But if they give you the total and one of the halves, don't forget you have to double one of the halves and set it equal to the total. So I think that's the trickier one of the 2. Okay, if you got any questions, don't forget you can shoot me an email or even a chat through the email feature, and I'll try to get back to you as soon as I see it. Okay, otherwise I will see you the next day at school.